Hi everyone. Welcome to Using Machine Learning for Security at Scale with Amazon GuardDuty and Amazon Macie. My name is Phil Rodriguez, and I'm a Principal Security Solutions Architect for AWS based in Sydney, Australia. In today's talk, I will be looking at two of our newest security services with a special focus on how they use machine learning to help solve the challenge of operating securely at scale. This is a 200-level intermediate talk, which means I assume you have a basic understanding of IT security and of AWS services. Our customers use the cloud for many different reasons. One primary reason that they use AWS is to take advantage of the size of our global infrastructure and the scalability that it provides their applications. You can quite easily run cloud infrastructure built on top of AWS that includes dozens of accounts, hundreds of VPCs, thousands of API calls, and millions of network connections. You can create dozens of applications using hundreds of S3 buckets or store thousands of documents that are accessed millions of times. One challenge when operating at that scale is detecting the single event that can have a large impact on your security. How do you detect when a single new EC2 instance starts up and makes a single connection out to a known bot command and control server? How do you know when a single user uploads a single document containing sensitive information to an S3 bucket with global read permissions? AWS have built and released Amazon GuardDuty and Amazon Macie to solve those challenges and help our customers operate securely at scale. Amazon GuardDuty provides broad protection of your AWS accounts, workloads, and data by helping to identify threats such as attacker reconnaissance, instance compromise, and account compromise. Amazon Macie helps you protect your data in Amazon S3 by classifying what data you have, the value that data has to the business, and the behavior associated with access to that data. Both services incorporate user behavior analysis, machine learning, and anomaly detection to detect threats in their respective categories. I'm going to talk about Amazon GuardDuty first and Amazon Macie second, and pick specific examples where we use machine learning to help you operate securely at scale. For the rest of this talk, I will refer to Amazon GuardDuty simply as GuardDuty and Amazon Macie simply as Macie. GuardDuty is a managed threat detection service that continuously monitors for malicious or unauthorized behavior to help you protect your AWS accounts and workloads. It monitors for activities such as unusual API calls, or potentially unauthorized deployments that indicate a possible account compromise. GuardDuty also detects potentially compromised instances or reconnaissance by attackers. Enabled with just a few clicks in the AWS Management Console, GuardDuty can immediately begin analyzing billions of events across your AWS accounts for signs of risk. GuardDuty identifies suspected attackers through integrated threat intelligence feeds and uses machine learning to detect anomalies in account and workload activity. When a potential threat is detected, the service delivers a detailed security alert to the GuardDuty console and to AWS CloudWatch events. This makes alerts actionable and easy to integrate into your existing event management and workflow systems. GuardDuty is cost-effective and easy. It does not require you to deploy or maintain software or security infrastructure, meaning it can be enabled quickly with no risk of negatively impacting existing workloads. There are no upfront costs with GuardDuty. There's no software to deploy, and no threat intelligence feeds are required. You pay for the events that are analyzed by GuardDuty, and there is a free 30-day trial available for every new account to the service. GuardDuty is an intelligent threat detection service that provides you with an accurate and easy way to continuously monitor and protect your AWS accounts and workloads. It detects activity that can be associated with account compromise, instance compromise, and malicious reconnaissance. For example, GuardDuty detects unusual API calls, suspicious outbound communications to known malicious IP addresses, or possible data theft using DNS queries as a transport mechanism. It does this by analyzing source data from your AWS accounts via AWS CloudTrail, which provides AWS user and API activity in your account. It also uses Amazon VPC flow logs, which provide network traffic data, and DNS logs, which provide name query patterns. GuardDuty delivers more accurate findings using machine learning enriched by threat intelligence, such as lists of malicious IP addresses and domains. GuardDuty provides low, medium, and high severity levels to help you prioritize your response to potential threats. A low severity level indicates suspicious or malicious activity that was blocked before it was compromised. A medium severity level indicates suspicious activity. For example, a large amount of traffic being returned to a remote host that is hiding behind the Tor network, or activity that deviates from normally observed behavior. A high severity level indicates that a resource, like an EC2 instance or a set of IAM user credentials, is compromised and is actively being used for unauthorized purposes. With one click in the AWS Management Console or a single API call, you can enable GuardDuty on a single account. With a few more clicks in the console, you can enable GuardDuty across multiple accounts. Once enabled, GuardDuty immediately starts analyzing continuous streams of account and network activity in near real time and at scale. There are no additional security software, sensors, or network appliances to deploy or manage. Threat intelligence is pre-integrated into the service, and we keep it updated continuously. GuardDuty was released in late 2017 and was available in 14 regions around the world, seen here on this slide. Please check the AWS Region Table on our website for which regions are supported when you watch this. GuardDuty is a regional service. Even when multiple accounts are enabled and multiple regions are used, the GuardDuty security findings remain in the same region where the underlying data was generated. This ensures that all data analyzed is regionally based and does not cross AWS regional boundaries. You can choose to aggregate security findings produced by GuardDuty across regions by utilizing AWS CloudWatch events, pushing findings to a data store in your control, like Amazon S3, and then aggregating findings as you see fit. Let's go into more detail about what GuardDuty can detect. The easiest way to understand what it is designed to detect for is to look at the lifecycle of a common attack seen by our AWS security team. At a basic level, the attacker attempts to compromise an instance, typically through an unpatched network service or a weak password, and then attempts to pivot to compromise the AWS account. The attack we're looking at here starts on the left of the arrow and continues along the boxes to the right. In this example, the attacker tries a list of known passwords against a remote desktop port. If one of these passwords match, then they try to install a remote access Trojan so they can keep control of the instance without the need for RDP. Inside of the instance, the attacker will look for any IAM credentials that they can find, for example, the temporary credentials an instance needs to communicate with external AWS services. They take these IAM credentials and then try them against many different AWS services via API calls, looking for access. They then use this access to do other things, in this example, like spinning up additional instances and using them to mine cryptocurrencies. All around this attack lifecycle are the specific types of detections that GuardDuty uses to alert you when it sees this type of activity. For example, alerts about new malicious IP addresses trying to access your environment, or a pattern of activity that indicates that an RDP brute force attack are good indicators of unauthorized activity. GuardDuty had about 40 different detections at launch, and we continue to release new detections based on our findings and based on customer feedback. At a high level, these are the 6 types of detection that we use. I'm not going to talk through all of these examples right now. Although we have to be opaque about how the service works, we are purposely transparent about what it finds. Our public documentation has a complete list of all of the finding types in GuardDuty and is a great resource in general about security detection in the cloud. GuardDuty offers advanced detections using machine learning and anomaly detection to identify previously difficult to find threats, such as unusual patterns of API calls or malicious IAM user behavior. GuardDuty also increases the accuracy of its findings using machine learning to help ensure it generates the least amount of alerts necessary to describe the activity. When GuardDuty detects suspicious or unexpected behavior in your AWS environment, it generates a notification that we call a finding. The finding details include information about what happened, what AWS resources were involved in the suspicious activity, when it took place, and other information. One of the finding types that uses machine learning is what we call behavioral alerts. These indicate that GuardDuty is detecting activity or activity patterns that are different from the established baseline for a particular AWS resource. The more advanced behavioral and machine learning detections take between 7 and 14 days to set a baseline of behavior in your account. After that time, the anomaly detections change from a learning mode to an active mode. Once active, you will only see findings generated from these detections if the service observes behavior that suggests a threat. Here are some examples of finding types that alert based on changes in behavior or unusual or anomalous activity. AWS uses machine learning and anomaly detection to determine what behavior is normal, to detect changes in behavior, and to establish what is unusual based on previous observations. Some examples of behavioral alerts are an IAM user launched an EC2 instance of an unusual type. An EC2 instance is communicating with a remote host on an unusual server port. And an EC2 instance is generating unusually large amounts of network traffic to a remote host. These alerts all look for behavior that's different from the established baseline. For example, the IAM user or EC2 service might have had no history of launching an instance of this type or communicating on this port. Examples of alerts that look for unusual patterns are an EC2 instance is querying algorithmically generated domains, multiple worldwide successful console logins were observed, and an API was invoked from an IP address of an unusual internet service provider. These alerts all look for patterns that are either unusual based on the baseline of activity within the account, such as from where in the world the account usually logs into the console, or patterns that are known to be suspicious, such as traffic that is being sent via DNS that does not look like a request for a name resolution. We are planning to add an additional 9 new behavioral alerts in February 2018. Let's switch now to take a look at Amazon Macie. Remember, GuardDuty provides broad protection of your AWS accounts, workloads, and data by helping to identify threats such as attacker reconnaissance, instance compromise, and account compromise. Macie helps you protect your data in Amazon S3 by helping you classify what data you have, the value that data has to the business, and the behavior associated with access to that data. Both services incorporate user behavior analysis, machine learning, and anomaly detection to detect threats in their respective categories. Both services use the same format for reporting alerts via CloudWatch events, and both teams sit right next to each other in the same office. The key difference between the services is that GuardDuty monitors your cloud infrastructure, while Macie monitors access to your data. Amazon Macie is an AI-powered security service that helps you prevent data loss by automatically discovering, classifying, and protecting sensitive data stored in AWS. Macie uses machine learning to recognize sensitive data, such as personally identifiable information or intellectual property. It assigns a business value and provides visibility into where this data is stored and how it is being used in your organization. Macie continuously monitors data access for anomalies and delivers alerts when it detects a risk of unauthorized access or inadvertent data leaks. You can use Macie to protect against security threats by continuously monitoring your data and account credentials. Macie gives you an automated and low-touch way to discover and classify your business data. When alerts are generated, you can use Macie for incident response, using automation based on CloudWatch events to swiftly take action to protect your data. Macie uses machine learning to better understand where your sensitive information is located and how it's typically accessed, including user authentication locations and times of access. Today, Macie is available to protect data stored in Amazon S3 with additional support for more AWS services coming later. Macie first creates a baseline and then actively monitors for anomalies that indicate risks and/or suspicious behavior, such as large quantities of source code being downloaded, credentials being stored in an unsecured manner, or sensitive data that is configured to be externally accessible. With a Macie console, your most important information is front and center, with detailed alerts and recommendations for how to resolve issues. Macie also gives you the ability to easily define and customize automated remediation actions, such as resetting access control lists or triggering password reset policies. Macie allows you to understand your data and also understand how that data is accessed. Macie uses machine learning-based classification of your Amazon S3 objects to provide visibility into your S3 environment. Macie can identify data with high business value, including programming languages, source code, logging formats, database backup formats, credentials, and API key formats. Amazon Macie's user behavior analytics engine helps identify risky or suspicious activity with AWS Service API calls and access to high-value content. It includes the ability to detect sudden increases in high-risk API activity, anomalous API activity through multiple locations or at infrequent hours, and increases in access to content that could indicate possible data loss. Today, Macie supports S3 and CloudTrail. In 2018, we plan to add additional support for user and content protection in EC2 environments, and also Amazon DynamoDB, Amazon RDS, Amazon EFS, and AWS Glue. GuardDuty was released in late 2017 and was available in 2 regions around the world, specifically US East in Northern Virginia and US West in Oregon. Please check the AWS Region Table on our website for which regions are supported when you watch this. In order to use Macie, you must have S3 buckets with the data that you want classified and analyzed in one of these supported regions. Macie analyzes activity of user, application, and service accounts associated with sensitive data that suggests risk to the business, such as inadvertent exposure of data, insider threats, or targeted attacks. Macie can alert on suspicious activity, such as compromised user accounts being enumerated, and downloading large amounts of sensitive content from unusual IP addresses, or the download of large quantities of source code by a user that does not typically access this type of sensitive content. One compliance-focused example includes detection of large quantities of high-risk documents shared publicly or to the entire company, such as files containing personally identifiable information, protected health information, intellectual property, and legal or financial data. Additionally, you also have the ability to use Macie's dashboard to define your own alerts and policy definitions based on your security needs. Let's take a look at some example alerts. After enabling Macie, one customer was alerted about a user in their environment who had uploaded an AWS secret access key to an S3 bucket. This knowledge helped the customer avoid a potential compromise, because if you remember from the GuardDuty attack lifecycle example, attackers try to get control of AWS accounts using AWS secret access keys. Another customer was alerted when a large number of EC2 instances were started outside of an auto-scaling group. Normally, when we see large number of similar instances all start up at the same time, it's because of a horizontal scaling feature of our platform. In this case, the account had been compromised, and this activity was an attacker trying to use all this extra compute power for inappropriate reasons. One final example was a customer who was alerted about a large number of files that were accessed by someone using an anonymizing routing service, in this case Tor. Luckily, this was because of research that one of their staff members was conducting, but in other cases, it might be a sign that an attacker has found a way to access your documents and is trying to cover their tracks. Those last 2 alerts are examples of where we use machine learning to help classify unusual behavior. Let's take a look at that in more detail. Macie uses machine learning in all three of its core functions. For user behavior analytics, Macie models user activity utilizing advanced node analysis and learning algorithms that can infer and recall higher order sequences. For automated document classification, Macie uses machine learning to label new topics and classify and label new content. For data loss prevention, Macie uses fully configurable matching of regular expressions and machine learning-based recognition of hundreds of different document types. Macie uses machine learning behind the scenes within the service itself. You can see the outcomes produced by this machine learning when Macie creates what we call predictive alerts. These are automatic alerts that are based on activity within your AWS infrastructure when it deviates from the normal established activity baseline. More specifically, Macie continuously monitors activity within your AWS infrastructure and builds a model of normal behavior. It then looks for deviation from that normal baseline, and when such activity is detected, it generates automatic predictive alerts. For example, a user uploading or downloading a large number of S3 objects in a single day might trigger an alert if that user typically only downloads 1 or 2 S3 objects over the course of a week. Macie also uses machine learning to determine what normal looks like when there is not enough data generated for a new user or a document to produce a baseline. It does this by using peer group analysis. For example, each user is modeled across several features that are recorded as one-day time series, such as the numbers of spreadsheets that are viewed in a day. Users are then grouped by similar feature profiles, which is another term for a peer group. For example, users with a high number of spreadsheets viewed in a day might be categorized into a peer group called people who view a large amount of documents. Macie then detects when a user's activity falls above the predicted range of values and also out of its peer group's range as well. This means even a user with only 1 day of activity might be flagged if that activity level is anomalous when compared to their peers. In this example, the final action is to create an alert with a risk level that is based on all tracked features and then combined into a single risk score. Another key area where Macie uses machine learning is through its automatic data classification engine. It is impossible to use regular expressions alone to classify sensitive data at scale because the volume of false positives would be too high. For example, classifying something as a phone number every time a certain amount of numbers appeared in a row would create too many alerts, which would overwhelm teams who are investigating these issues. Macie uses machine learning to increase its ability to automatically detect sensitive data and sensitive data types in the potentially millions of documents you store on S3. For example, Macie is able to make automatic decisions about which of these might be a high-risk document, or which data includes personally identifiable information, or to recognize source code from other document types. A final example of how Macie uses machine learning is to provide context to what could be a high volume of alerts per month, which allows them to be linked into a single alert. It's not useful to provide you with hundreds of thousands of alerts per month. In fact, it's counterproductive since most organizations do not employ a lot of people with cloud or security skills. Macie uses machine learning to understand all of the activity that is related to a single event and condense all of that activity into a single alert. Our goal is to only generate a handful of alerts per day, no matter how large your organization is. We're approaching the end of this session, so let's do a quick review on what's been discussed before, and then I'll share with you some next steps. We took a look at 2 new security services from AWS. Amazon GuardDuty provides broad protection of your AWS accounts and workloads and data by helping to identify threats, such as attacker reconnaissance, instance compromise, and account compromise. Amazon Macie helps you protect your data in Amazon S3 by helping you classify what data you have, that value that data has to your business, and the behavior associated with access to that data. Both services incorporate user behavior analysis, machine learning, and anomaly detection to detect threats. We use machine learning to help determine what normal looks like in a set of data so we can determine when an anomaly has occurred. We use machine learning to help automatically classify items like risky documents or sensitive data. And we use machine learning to help identify similar activity so the services only generate the minimum number of alerts necessary to warn you when something suspicious is occurring. You are attending an online virtual conference right now. You're sat down in front of your computer or maybe a mobile device. This is an AWS conference, so I assume you already have an AWS account. If not, then go create one right now. I want you to open up the AWS console, search for GuardDuty, and turn it on. GuardDuty is free for all users for the first 30 days. Next, I want you to search for Macie in the console, remembering that you need to have buckets with data or CloudTrail logs in US East or US West to use the service, and then turn Macie on. It has a free tier available for up to 1 gigabyte of content and up to 100,000 events. The best way to learn about both of these services is to use them. Go ahead and just turn them on. This talk covered both GuardDuty and Macie, so I did not get a chance to dive too deeply into either service. For more detailed information about each service, please check the recording and slides from our Global AWS reInvent 2017 conference. You can find 2 separate 1-hour-long talks on GuardDuty and Macie, including live demos of each. The links to these 2 talks are available, or use a search engine to look for the keywords on this slide. You have several options available to continue to take your AWS knowledge to the next level. Our instructional videos and self-paced labs are a great way to gain more confidence about the cloud and more hands-on experience with AWS. You can also attend our instructor-led classes by qualified AWS instructors and learn how to design, deploy, and operate highly available, cost-effective, and secure applications on AWS. And finally, don't forget to validate your technical expertise with AWS and use practice exams to help you prepare for one of our many AWS certifications. Thanks very much for attending this session today. I encourage you to continue to watch the other great talks that we have. At Amazon, we always value your feedback. It helps us constantly improve. Please take the time to provide some feedback on today's event. Thanks again and have a great day.